Okay, so today we are doing sines, cosines, and tangents. We're looking at the unit circle. And we'll start off now with this. So consider the rotation of r theta, magnitude of theta with the center at the origin. So here we have theta, that's the amount of the angle right there. Regardless of the value of theta, the image of 1, 0 under r sub theta is on the unit circle. So on this, so the image goes from here, this was the pre-image starting at this point, it becomes P over here because the angle moved theta amount. So this is point P. The x value right here is the cosine of theta. The sine of theta is the y-coordinate of P. So in order to find this point right here, this is the x value, you're going to put in theta into cosine to find out what x is. You put theta into sine to find out what y is. Example, we want to find out what cosine of pi is. Well, cosine of pi is at this point on the unit circle. We know that one full revolution all the way around the unit circle is 2 pi. So 1/2 revolution is pi. If the radius of the unit circle is 1, this point is at -1, 0. So the x value, cosine pi, is -1. The y value, cosine pi, is 0 in this case. On this unit circle, we have the value of x of 1 and the value of y as 0. There's two ways that we can come out with those values. And this is how we can write it. We can have an x of cosine 0, that's in radians, or cosine 0 degrees. And we can have a y of sine 0 in radians or sine 0 in degrees. So in other words, this value, 1, 0, can also be written out as cosine 0 sine 0 or cosine 0 degrees sine 0 degrees. At this point right here at 90 degrees, the value of x is 0, the value of y is 1. I could write that as cosine 90 degrees sine 90 degrees. If I wanted to write this in radians, I would write cosine of pi over 2 because 1/2 of the circle is at pi. So therefore, 1/2 of a half is pi over 2. And this would be sine pi over 2. On this side of the circle, I could do cosine of 180 or sine of 180 for my circle, and this is the value that comes out for my ordered pair. Or I could say cosine of pi, sine of pi. And then at the bottom, I have 3/4 of the circle, which is the same as saying cosine of 270. Oops, that should be 70. Sine of 270. And I could also say cosine of 3 pi over 2 or sine 3 pi over 2. So we want to look at tangent. What exactly is tangent? In this case, tangent is sine theta over cosine theta. when cosine does not equal 0, or does equal 0, which occurs at any odd multiple of 90 degrees, tangent is undefined. So let's look at the unit circle for a minute. So at this point right here, cosine is at 0, and sine is at a positive 1. At this one right here, cosine is at 0, and sine is at negative 1. At those 2 points, that is when tangent is undefined, because you cannot divide by a 0. So if you think about sine theta is the same thing as saying sine 90 degrees in this case over cosine 90 degrees. Well, the sine is 1, but the cosine is 0. 1 divided by 0. You can't divide by 0, so it's undefined. You can do the same thing for the bottom here. This one says evaluate tangent at pi. Well, back to the unit circle above, we know that pi is at this point. We also know that the coordinates there is negative 1, 0. So tangent at pi is sine of pi over cosine of pi, which is equal to 0 over negative 1. So this equals 0. Evaluate tangent at negative 270. Well, 270 is 3/4 of the circle, but we are going the negative direction. So starting here, we're going around to this point, which is the same thing as saying tangent of 90 degrees. So tangent of 90 degrees is sine of 90 over cosine of 90. Well, sine of 90 degrees is 1. Cosine of 90 degrees is 0. So this is an undefined tangent. On this one, we want to evaluate tangent for 450 degrees. Well, we know a full rotation around the circle is 360 degrees. So this is definitely more than one rotation. But we only really need to figure it out for the amount of difference between 450 and 360. So I can subtract that. And that's 90 degrees. So tangent at 90 degrees is the same thing as saying sine 90 over cosine 90. And we just did that. We already know that sine is 1 there and cosine is 0, so this is undefined. Evaluate tangent for 4 pi. Let's make a unit circle for this. We know that this point right here is at 2 pi. So if I go one full rotation around, that's 2 pi. 2 full rotations around is 4 pi. So evaluate tangent at negative 4 pi. Instead of going counterclockwise, we'd be going clockwise, but you still end up at this point, which happens to be at 1, 0. So sine of negative 4 pi and cosine of negative 4 pi is the same thing as saying sine of 0 over cosine of 0, which happens to be at 0, 1. So tangent at that point, 0 divided by 1 is 0. Suppose the tips of arms of a starfish determine the vertices of a regular pentagon. A pentagon has 5 vertices. So here we have a picture of this. We have 5 arms of a starfish. This is 1, this is 2, 3, 4, and 5. And a regular pentagon means that all sides are equal and all vertices are equal. So if I want to find the rotation from A to B, which is what it's asking me for, I want to find out what the coordinates at that place is, at B. A full circle on this is 2 pi. But we only want to go 1/5 of the way. So I'm going to take 2 pi and divide it by 5. That's how much theta is going to be. So we're going to take sine of 2 pi divided by 5 and cosine of 2 pi divided by 5. Now, because we are using pi in this radians, we need to make sure our calculator is on radians. So make sure you go to your mode and convert to radians. If you do not, your answers will come out wrong. If we were in degrees instead, you would want to make sure that you were in degrees. Put this into your calculator and you're going to end up with about 0.951 for sine and about 0.309 for cosine. So the coordinates of this point are 0.309, that's the x value, 0.951 for the y value. You would do this the same way, except this time they gave you the amount of rotation. The one before we had to figure it out. So once again, we got to make sure that our calculator's in radians. And we're going to go and find cosine of negative 10 pi over 9 and sine of negative 10 pi over 9. When we do that, we get negative 0.940 and 0.342. It says, based on your answer in part A, tell whether the tangent of negative 10 pi over 9 is positive or negative. Well, the cosine is negative, and this, the sine is positive. So if I'm going to have sine over cosine, and in this case the sine is positive over a negative, when you're dividing a positive by a negative, it makes it a negative. So our tangent would be negative in this case. For the given value of theta, you can determine whether or not the sine theta or cosine theta or tangent are positive and negative without using a calculator by using coordinate geometry and the unit circle. So here's our circle on the right. At quadrant 1, that's right here, our x values are positive, so cosine theta is positive. Our y values are also positive, so sine is positive. And then our tangent, because these are both positive, will also be positive. Because a positive divided by a positive is a positive. In this quadrant, our x values are negative, but our y values are positive. We are taking a positive divided by a negative, so this will be negative. In quadrant 3, we have still negative x values, but we also have negative y values. So a negative divided by a negative makes it a positive for tangent. In quadrant 4, we have positive x values, negative y values, but since we have a positive divided by a negative, this will also be negative.